Good evening, everyone. We're just waiting for 2 more minutes, and then we'll start with the session.
Madam, wait for
This is
couple of minutes. Wait
okay.
for couple of minutes. Wait for couple of minutes. People are joining.
Okay.
Reena, madam, we may
Yes,
start.
sir.
Yes.
Okay.
Yes.
So, very good evening to everyone present. I, Dr. Ruhina Kazi, Head of the Department, Electronics and Telecommunication Engineering, Anjuman College of Engineering and Technology, Nagpur, Maharashtra. Welcome you all to the second day of Atal Online 6-day Faculty Development Program titled Harnessing AI Technologies for Sustainable Rural Agriculture from 17 to 22nd February 2025. Today, the first session is again from an industry expert, and the topic is Role of AI Focusing Sustainable Growth in Rural Development. And this will be delivered by Mr. Ashwin Kumar Gopichand Balani. Mr. Balani is the current CEO at First Impression Technologies. He is proficient in many technologies, including both not limited to Android app development, Flutter, MATLAB-based signal processing, Net frameworks, PHP and its frameworks, VHDL-based designs, blockchains, cryptography, cryptocurrencies, and many more. Phytech currently undertakes both research and industry projects under his guidance, and he has completed around 200 plus projects. He started Phytech in 2009 and is spearheading the design and development division. Some of his valuable contributions include training modules for Indian Army, part of the design team for development of a graph database testing engine for Facebook, and surveillance app for Naxal tracking. He is also an active member of Startup Leadership Program, Mumbai chapter, and was awarded as the most dedicated entrepreneur for the year 2016-17. He is also the program leader for 2017-18 SLP batch. Working on technologies like Android, iOS, PHP, MySQL, Oracle, MS SQL, .NET technologies, Flutter, and many more for more than 10 years. Developed and delivered over 1,000 projects for local, national, and international clients. He founded apps like Random Questions, ICT, Khabri. He has clients including Indian Army, police departments, ordnance factory, connecting wires, and many more. So that was his brief introduction. Now I request Balani sir to kindly continue with the session. Balani sir.
Good evening, everyone. Thank you for the introduction, ma'am. So today we have a bit of a less time. We have to cover a lot of things. So I'll simply start with the session. I have a couple of things that I want all of you to please try and follow. One thing is that 70-80% of the session will be coding. So you will be actually designing a model that will help farmers to do some sustainable development things. So I would request all of you to start your laptops and be on your laptops whenever possible. Secondly, we will be doing all the coding in Colab. So I'll just give you 2 minutes of time and I'm sending you the link for Colab. Please start Colab on your laptops. So Colab's link is given on the chat window. Now please open that. And once you are done opening Colab, just write done on the chat window so that I know that everyone is started with Colab. And once we are done, I'll start with the presentation. There will be 15-20 minutes presentation that I'll be showing you to explain you what is the role of AI in sustainable growth and rural development. And after that, we'll be looking at a real-time use case or an example. And then you will code that example on your own machines. You don't have to actually code. I'll give you the code via my Colab notebook. You can just copy the code into your own Colab. And based on that, we'll complete the session. So I would request every one of you to please open Colab. And once you are done opening Colab, write done on the chat window. We'll wait for 2 minutes of time. I think everyone is able to hear me and we all are actively in this workshop. So if you are done, just write done on chat window and we can move ahead. Thanks, Ajit sir. If you can write done on chat window, it will be much easier for everyone to know that we are done with that. Thanks, Ajit sir. Okay. Thank you, Sujan sir. I think I'll just start with the PPT. I would request all of you to please open Colab on your machines, and once you are done, uh, just write down on chat window. So I think everyone can see my screen now. Yes or no? If you can see, just type yes.
Yes,
Yes, sir. Yes.
Perfect. Now, even if you are on your mobile phone, you can click on the Colab link. It will open a Colab notebook for you. So I'm just telling you how to do it. I think most of you might know it, but for those of you don't know it, just click on this Colab link. It will open a Google Colab environment. Click on New Notebook over here. It will open a new notebook for you, wherein we'll be coding in some time. So don't worry about the code right now. You just keep it started and click on connect over here. So if you click on connect, it will connect your notebook with Google servers and you can perform the code. Okay, so with that knowledge, let's move ahead and understand what is the topic of today. So the topic for today is sustainable growth in rural development using machine learning or AI powered systems. So first we have to understand what is the meaning of sustainable growth. What is the requirement of this? Right? Actually, when you are saying rural development, when you're saying development of a rural system, why do we require sustainable growth? And what is the meaning of sustainable growth? So, as all of you know, that there is on this earth, the resources are limited. And because of these limited resources, we cannot just keep on wasting resources or wasting uh, things that are available with us. For example, whenever a farmer farms in his farm, at that time he might overuse water or he might underuse water. Okay. If he overuses water, then there are three problems that might occur. First, the water bill that he might get will be higher. Second, the wasted water might not ever come back. Third, the quality of land, that is the land quality where you are actually uh, wasting water, that quality will also reduce. So, in such a case, that land might not be able to sustain the development for a longer time, or it might not be able to grow seeds for a longer time. So, in that case, what we can do is we can create an AI powered smart system wherein that system can sense all the parameters of the land, like temperature level of the environment, humidity level of the environment, and multiple other parameters. Based on these parameters, the system can actually tell you for which crop type how much water is required. And if you give that much water per hectare of land, then the farming will be sustainable. Are you able to get that point? If you're able to get that point, just type yes on chat window, else I can repeat that once again. Yes, class, be active. If you're able to understand that point, just type yes. Thanks, Albert. So I think we are able to understand the point that we are, thanks, Laman. So we're able to understand that point that we need to design AI systems that can help rural development and in this way. Thanks, Niranjana ma'am. Thanks, Divya ma'am. Thanks, Ajit sir. So let's see what is the need of this. So first things first, the main need of this particular thing is that the farmers in rural areas struggle with inefficient water usage, as I told you previously. Over irrigation will lead to damage of soil. Under irrigation will lead to crop yield uh, levels. So if they do a lot of water, if they spend a lot of water, then the soil might get damaged. If they don't use water that much, then the crop yield might get affected. So in that case, we require a AI-driven solution to optimally plan irrigation. And then we want to have a solution where uh, the system should tell me that how much water should I use in a per hectare area, and based on that, I'll be able to use that particular thing. So let's say, what will the AI model do? The AI model will first sense the temperature level, the humidity level, the soil moisture level, the current rainfall level, and the crop type. So based on the temperature, the humidity of the environment, the moisture level of the soil, and the rainfall which is currently present, we are able to, and the crop type which we want to grow over there, the farmers will be able to get recommendations as in how much water they should put for that particular crop. Okay. For example, we'll create an AI model that will be trained on a synthetic set. Why synthetic? Because you can either use a real-time data set or a synthetic data set. In this case, because we don't have so much time to go inside the data set details, so I've created a synthetic set. You can always replace that with a real-time set. Now the features of that particular set are temperature, humidity, soil moisture, rainfall, and crop type. For example, if temperature is 20 degrees, humidity is 30%, soil moisture is 10%, and there is 100 millimeter of rainfall, and you want to grow maize over there. So if you give all these features as the input, the model will be able to produce the output as the predicted irrigation level, as in how much liters of water you require to irrigate that particular land. Okay, is that clear with us? Yes or no? If it's clear, just type yes, else I can repeat that once again. Thanks, Ajit sir. Thanks, Rasuddin sir. Thanks, Verena ma'am. Yeah, I think it's clear to most of you because it's a very simple problem statement that I took so that everyone can understand the concept behind it. So, which algorithm that we want to choose over here? We're selecting a random forest algorithm. Why random forest algorithm or random forest regression? Because let me just show you what kind of data we are trying to process. So this is the data that we will be getting when you run the code. We get a temperature level, a humidity level, soil moisture level, rainfall level, and crop type. There are 1, 2, 3, 4, 5 variables, and the output is the irrigation level. So basically, the equation that we are trying to solve is irrigation level equals to some weight W1 into temperature plus some weight W2 into humidity plus some weight W3 into moisture level plus some weight W4 multiplied by rainfall plus some weight W into crop type. That is the equation that we want to solve. This equation has 5 dependent variables: temperature, humidity, moisture, rainfall, and crop type. So for all these 5 variables, we require multiple regressors, as in we require multiple models that can actually use those inputs and produce an equation at the output. So we can either use a random forest regression, because what this regression will do is it will create a different tree for every input, as in it will create one tree for temperature, one for humidity, one for soil moisture, one for rainfall, one for crop type. It will create one tree that combines temperature, humidity, one tree that combines temperature, soil moisture, and so on. So because we have multiple inputs and we want to map multiple inputs to one output, that is why we are using a random forest regressor. You can also use linear regressor. You can also use univariate regressor. You can also use spline regressor. There are many regressors that you can use over here. But for this particular problem, wherein you have multiple inputs and you want to get a single output at the result, at that time we use a random forest regressor. Secondly, if you see the data, the irrigation level is a number, as in it is not a discrete number, it's a continuous number: 350.2, 266.2, 350.4, 318.7, 370.4, which means there is no fixed value at the output. The output can have infinite number of values. So in that case, you cannot use the classification method. You have to use a regression method. Classifiers are used when you have multiple inputs and you want to find out a single output which is discrete, as in in this case, if I get temperature, humidity, soil and soil moisture and rainfall, and I want to classify with these inputs which crop type I can sow over there, that will be a classification problem because the outputs are limited. There are only 4 crop types as we saw, 0, 1, 2, 3. That is why this, if we take this kind of problem where when we have multiple inputs and the output has fixed number of entries or fixed number of values, then we can use a classification problem, or we can use a classifier like CNN or RNN or KNN, any classifier we can use. But because the output has multiple levels and these levels don't have any fixed value, that is why we are using a regression model. Are we clear with that? Yes or no? Because the main purpose over here is for us to understand why a regressor is used over here and why not a classifier. Are we clear with that? Or if you want, I can repeat it once again, no problem. Okay, thank you, Raman sir, for telling me that it's not clear. Asking questions is very, very good because I too get a sense that you are able to understand that. So, Raman sir, there are 2 kinds of methods that you can apply over here. One is called a classifier. Classifier means you have a fixed set of inputs and you have a fixed set of outputs. Means if I want to find out in a particular area which crop I can grow. For example, if the temperature level is about 29 degrees, excuse me, humidity is about 41, soil moisture is 28, and rainfall is 134. Based on this data, if I can only grow wheat over there, so wheat is a fixed output. So that to classify this input into wheat, we require a classifier. Are we clear with that? Yes or no? Very good. Very good. Like Manish sir, I'll just come to your query in 1 minute. Secondly, why can't we use the classifier over here? Because we want to predict the irrigation level or the amount of water that is required to have optimal irrigation, as in so that the water is not wasted and the water is not underutilized. So the water level can never be 0, 1, 2, 3. Water level will be in 300 liters, 450 liters, 500 liters. So the number of levels of output is not fixed. That is why we use a regression model. Are we clear with that? Yes or no? Perfect. Now coming to the 2 queries that are raised, can we use CNN for continuous values as well? Yes, we can use for CNN continuous values as well. For that, you require a 1D CNN. 1D CNNs can do this task, but again, CNN is a classifier, not a regressor. So you cannot use CNN to predict irrigation level. You can predict CNN, you can use CNN to predict crop type, but not to predict irrigation level, because CNN will have a very low accuracy. It might have accuracy of 1% or 2% because the number of classes are very, very high at the end. Ruhina ma'am is asking, shouldn't be it in range? Perfectly fine. If the irrigation level was in range, as in if I can do a low irrigation or a medium or a high irrigation, then I can definitely use the classifier. But here I don't want the range of the irrigation level. I want to know exactly the amount of water that is required. That is why you cannot use a range over here. Are we clear with that? Manish sir and ma'am? Perfect. Thanks, Rina ma'am. Manish sir, is your query clear? Perfect. So now that is what we want to do over here. So that's why we are using a regressor model. Now what we'll do is we'll do a training of the model wherein we'll use the previous data to predict the irrigation outputs. And because we are using a regressor model, so we'll be calculating the error, that is the mean absolute error and the R-square score. I'll explain you both the things as we go along, but just understand that the mean absolute error should be as low as possible, which will indicate that whatever input you will give, that input is correctly produced as the output with minimal error. Meaning what? If the error is low, then if you give any values for temperature, humidity, soil moisture, rainfall, crop type, the output prediction will have high performance, or the output prediction will be at a very accurate level with minimum error. If the error level is say 10, for example, so you can assume that if you give any input, then the output will be plus 10 liters or minus 10 liters. As in, if you give any input, the output's accuracy will be either up to plus 10 liters or minus 10 liters. So the maximum wastage of water can either be minus 10 liters or plus 10 liters because the error is 10. If the error is 100, that means your model, whatever output it will give, the maximum amount of water that might be wasted is 100 liters. So it's very, very high. That is why the error should be as low as possible. The reverse of error is called as R-squared score, wherein the higher the R-squared score, the better. Okay. Are we clear on these 2 points? Yes or no? Perfect. Thank you, ma'am. Thanks, Prabin sir. Thank Manish sir. Perfectly. Okay. Let's move ahead with this. So we'll use a UI which will be built on a Gradio interface. I'll show the interface to you in 1 minute. And farmers will actually input the field conditions, and the AI will predict the irrigation level and provide the readable advice. Now, these 2 things are very, very important because our topic for the day is sustainable growth in rural development. So when we say rural development, we have to make sure whatever system we build, that system should be accessible to the farmers, and the farmers should be able to input the data easily, and they should get proper advice which they can understand. Okay, so that is what we are trying to build over here in a proof of concept kind of a thing. I'll show that to you. You'll be able to understand that. So let me give you a small example. The input is a temperature, which is 36 degrees, humidity 55, soil moisture 35, rainfall 40 mm, crop type rice. So if these are the conditions and I want to soak rice over there, then the output will be like you have to spend about 260 liters of water per hectare, and it will say that high irrigation is needed. Consider water conservation. Means when a farmer will read this thing in Hindi, that irrigation level आपको बहुत high चाहिए और water को आप अच्छे से use कीजिए. Because right now, for the sake of the workshop, we're showing this in English, but at the end we can convert this into any language that we want using Google Translate. So the actual output will be like आपके लैंड पे 260 लीटर्स ऑफ वाटर लगाइए जब आपका टेम्परेचर, ह्यूमिडिटी, सॉइल मॉइस्चर, रेनफॉल का लेवल ये है, एंड क्रॉप टाइप आपको राइस चाहिए वहां पे. और क्योंकि आपका इरिगेशन लेवल हाई है, मींस आप 250 लीटर पानी यूज कर रहे हैं पर हेक्टर, तो आप वाटर को कंजर्व करके स्टोर कीजिए. Are we clear with that point? What is the input and what is the output? Yes or no? Thanks, Rina ma'am. Thanks, Pravin sir. Thanks, Ajit sir. I think it's very clear. It's a very simple example. Thanks, Pinaka ma'am. Now, what is the benefit of this particular thing? First, is that it will reduce the water wastage because we are doing precision irrigation for the system. Second, it will increase the crop yield because water is being used properly, so the crop will be available, or the soil will be available for growing for a long time. Third, it will save the cost to farmers because light will be less, water will be less. Fourth thing, it's scalable because you can integrate the model with IoT sensors for real-time monitoring. So we get temperature and humidity with LM35 sensor. There is soil moisture sensor available. There's a rainfall sensor available. In crop type, the user can select from a UI. So based on these parameters, the result will be clearer to the farmers. Okay. In future, we can do a lot of things that we want to do. We can do real-time monitoring. We can do a mobile app. We can do IoT-enabled irrigation system, and we can use sustainable health monitoring of the soil as well. So all these things we can do in the future with this code. But for now, we'll stick to our problem statement, as in we want to give these inputs to the system, and the system should be able to produce these outputs. Okay. If that is clear with us, we'll directly jump into the code. Now, the way this code will be given to you is I'll be sharing my notebook with you one by one, line by line. You have to just copy the code from my notebook into your notebook. Okay. So I'm just sharing this particular notebook with every one of you. And I'll just click on share. And I'll just with link, copy, and I'll just paste the link on the chat window. So if you just open this particular link, you will be able to see my notebook, which is a blank Colab notebook. Okay. I'm giving the title of the notebook as Workshop Admin, so that you know that this is not your notebook, this is my notebook. Okay. If everyone has opened that notebook, please type OK, and then we can move ahead from there. Thanks, Pinaka ma'am. I think you have opened the notebook. Very good. You might be getting a blank notebook. It's perfectly okay. So first things first, we just install some libraries. So I am copying this code in the notebook, in my notebook from here to here, and clicking on run. Just refresh the page. You will get this particular code in your Colab thing. Just copy this code from here and paste in your notebook, and then paste into your part of the code or into your Colab notebook. I think this should be it. I hope you are able to understand what you have to do. Just refresh my notebook, means refresh this particular link. You will get this code, the code that I have just shared. Copy this line of code into your Colab notebook, as in the notebook that you have opened for in your account or into your Colab, where you click on new notebook. Just paste this particular link into your notebook and click on run. Once you're done, just write done, and you should be able to get an output like this, that all the libraries are installed. Yes. Are we done with this? Yes or no? So I'm repeating the process once again. Yeah. So what you have to do is click on my notebook, as in the link that I just shared with you. This link that I've shared, just click on this link and a new notebook will open. This is my notebook, the admin notebook or the workshop admin notebook. You don't have to change on this notebook because you'll not be able to change it. Okay. This code, this pip install code, you copy from here. Click on copy this code. And at the start of the workshop, I told you to start a new notebook in Colab. So if you went to Colab, clicked on new notebook. Inside this new notebook that you have opened, just paste the code and click on run. Paste the code and click on run. That's it. I think we are done with that. Yes or no? If you're done, just write done. Else I can repeat it once again. Just copy my code into your notebook. That's it. Done, everyone? Yes, class, are we done? So that I can move ahead. Thank you, everyone, sir. Rubina ma'am, are you able to do it? Ajit sir, Pinaka ma'am, Kuldeep sir, are you able to do it? Thanks, Shubhangi ma'am. Okay, so once you're able to do it, click on plus code. Okay, and you'll get a new code tile over here to actually write some code. That's okay, we can wait for a minute. Click on plus code, you'll get a new code window or a new code prompt over here. Okay, and then inside that particular prompt, you have to copy this code. So just refresh my code, you will get, just refresh the link that I sent you. You will get this entire code. Copy this code and paste inside your Colab. And then run the code. You'll be able to see something like this: temperature, humidity, soil moisture, and so on. If you're able to see that particular thing, just copy this result from here and paste in chat window so that I know that everyone is on the same page. If you're able to do this, just copy this output that you're getting and paste on the chat window. Rohina ma'am, are you able to install the libraries? Pip install. Is it done? Perfect. Now refresh my page, the page that I've given you, this page, this link. Once you refresh this link, you will be able to see this new code which is there. Just copy this code and paste that code into your Colab notebook. Once you are done, just write done on chat room and move ahead.
Ashwin sir.
Yes, ma'am.
Right. If you're going for right click, there are many options like copy link to cell, copy selection. So should I go for copy selection?
Yeah, you can also press Control A, Control C. It
Okay.
will copy that entire thing. Control A, Control C.
Okay. Okay.
Actually, I can paste the code in the chat window, but the chat window is very limited, no? That is why the whole code will not come there. So you have to refresh my window every time and you will get that code. Okay, once you are done, just copy the output that you're getting and paste on the chat window. Like I have got this output. Whatever output you're getting, just paste on chat window. If any problem, just unmute your mic and tell me. I'll just sort that problem out. Very good. Just click on run after you have pasted. When you click on run over here, you will get this output like this, something like this.
Sir, how to run that?
Sir, on the left side, you can see a run button, this black button.
Yes.
That button, it will run the code.
Okay.
Yeah,
Run cell, it is there.
Yes, yes. You have to run both the cells, huh? This previous pip install cell as well, and this new cell as well. You have to run both the cells.
Which one?
The previous cell that we did, pip install.
Install, I didn't do it.
Yeah, just So just refresh my collab. You will be able to get this code as well, pip install. Copy this code into your collab and then run that cell as well.
Okay.
So like you did for this code, the code that I gave you, similarly, you have to do for the previous cell as well. So this, you have to control a copy and paste into your collab and then run this cell. It will install the libraries basically. I think Vaibhan Lubin sir has got the output. Rubina ma'am, just click on run on the left side and paste the output of the output window, this window. Copy this output from here, copy selection, and just paste on the chat window. Are we done with that?
Sir, so could you repeat once again regarding the pasting of the output?
Yeah, just go on. Have you got this output in your screen?
Yes.
Yeah, just select this.
Sir, in the while copying, only we have to copy that install Gradio pandas is there one line. That or entire thing we have to copy.
Only this pip install.
First line only.
First line only. The second line is the
Okay.
output of that. The line that you are getting the white line, no? This is the
Yeah.
output of that. You don't have to copy the output. Only
Okay.
copy the pip install line and run it on your machine. Rohina ma'am, just copy this output, the white background one,
Okay.
and paste on the chat window.
Okay.
Yeah, I think Rohina ma'am has got the output. 2A technology has got the output. Very good. Very good. That's wonderful. So this is the data generation part, when we have generated a synthetic set which contains temperature, humidity, soil moisture, and so on, and it is showing you some output. Okay. If everyone can just paste their outputs so that I can know that all of us are on the same page. So I think Paivan sir has got the output. I think Trade Technology user has got the output. If anyone else has got the output, just paste on the chat window and we can move ahead.
After install, what we need to do, sir?
Just click on run, sir. Just click on run cell.
I ran that, but I don't get that. But whatever you have got the output initially, I got that.
Perfect.
But after that, what we need to do?
Then run the second cell. This one.
Second step, what I need to do?
Have you copied this code?
Yes. The second code I didn't copy.
Copy this code, sir. Copy the
Which
second,
one?
the second code. This code on the second cell.
Second cell. What is that? Import numpy.
Yes. Just
Up
click
to
on.
what?
Just click. Press Control A, Control C. It will copy the entire thing and paste inside your code.
Control
A, Control C.
Control A and C.
Yeah, Control A is for select all and Control C is for copy. I think Rohina got the output and I think Pinakam got the output. Very good. Sir, you got the output?
No, sir.
Um,
What is the button we have to press? Control?
Control A, or you can go to edit and select all.
Select all cells.
Not select all cells, it will select everything. Just press Control A over here. Control A, it will choose all the cells. Right click and says copy
I
selection.
got it selected.
And now right click, say copy selection.
Copy
Selection.
Copy selection
And then
and paste it in the this one.
in your notebook, correct.
My notebook, where I need to paste?
So
Code.
when just click on plus code, it will create a new code, paste over here.
Okay.
Done?
No, sir. Control We need to
Control
do
V.
Control V or
Control
what
V. Control
for
V. Control V.
pasting?
Control V. Control V.
Control V.
Yes.
Just a minute. Edit.
Okay. So once you have done this thing, let's move ahead. So you got the output?
No, sir. Now I have to how to copy it?
So Control C.
No. You said edit and then copy selection.
Copy selection, yes. And then paste in your
Copy selection is not there. It is copy set or cell or selection. It is there.
no, sir. I think you just click on select cell, or just right click on this and say, or just say Control A and Control C.
Control A.
Control C.
Control A or and C. No, it is not working. I think.
That's
Actually-
okay. We'll come to
Only one
that.
code is there.
We'll come to that, sir. Don't worry. Just look on the screen for a while. I'll give this entire notebook to you. You can just use that later. Okay.
Okay,
Or-
sir.
Perfect. Or sir, if you are not able to copy it, in my notebook, click on run. The notebook will run itself. No worries.
Okay.
Okay. Now,
Your notebook, I have to run. Na?
yeah, click on my notebook and run. It will say run anyway. Just run the notebook.
Run
It will-
has to be done on the from import numpy is there
Yes,
or
yes, from the starting. From the starting.
from the starting.
Yes, yes.
Run anyway. It is asking.
Yeah, anyway, yes, please. Okay, so I think every one of us are
Yeah,
now
I
able-
got that, sir. Temperature, humidity, soil moisture, rainfall, crop type, irrigation level.
Very good. Now, let's move ahead for the third part of the code, wherein we'll be using the random forest regressor. So now what we are doing is, we have got the input variables as temperature, humidity, soil moisture, rainfall, crop type, and the output variable is the irrigation level. So we did all the inputs in X, all the outputs in Y. Now we divided this X and Y into train and test. As in, all the results that you are getting from X and Y, you split them into two parts, training part and testing part. The training part will be used to train the model, and the testing part will be used to check the efficiency of the model. Now, we are using a random forest regressor, and we are using 100 estimators. As in, we are saying for this particular problem, there might be multiple combinations of inputs. So you use 100 trees or at the max 100 combinations of the inputs you use, and you fit the model. Once you fit the model, at that time, Govika, is there any query that you want to ask? Govika? I think her laptop might not be working properly. That's okay. So we are doing a random regressor to train the model. And once the model is trained, we do model.predict to test the model. And you remember, I told you that we have something called as mean absolute error, or MAE. We find out the absolute error between what output we have got and what output we should have got. So Y test is the output that we should have got, and Y predict is the output that we have got. Between these values, we get the error value. So if I run this particular code, I will be able to get the error level. So what you have to do is just refresh my window. You will be able to get this code. Click on run, and you'll be able to get the output as MAE 11.03 and R square score 0.98. Whatever output you are getting is paste on the chat window. For those of you who are not able to copy the code from my Colab, you can run the code in my Colab only. No problem. You should be able to get the output there.
Sir, how to refresh it?
Just press this refresh button. Reload this page.
Where is that refresh button?
Sir, at the top, just look at this reload button. Reload.
Top it is there.
Yeah, just the like normal refresh that you do, no? Normal refresh of the page.
Actually, where is this smart agriculture analysis code?
Which one,
Workshop is there.
Workshop admin, yes.
No, workshop that I have run.
So
What
just,
about smart agriculture
so
analysis?
just refresh this page again. You will be able to get my code.
page?
I got that mean absolute error 11.03 R square 0.98. What is this?
Yeah, this is the output that you're getting, sir. So let me explain.
Now,
you-
what I need to know,
nothing,
sir?
nothing. I'll just explain you what output you're getting.
Yeah.
When you say mean absolute error 11.03, that means
Yeah.
this particular model can predict the output of the amount of water with an error of 11. Means whatever
Okay.
output you will get, in that output, the amount of water spent might be 11 liters plus or 11 liters minus.
Okay.
So if you're running on my Colab, you should be able to get the same output. In your Colab, you might get different output. Okay. So Plevan sir, what output did you get? Just copy the output on the window and let me know. Like Rohina ma'am got the same result, 11.03 and 0.98. If you have got some different outputs, just paste on chat window and we can move ahead. Very good. I think most of us have got the similar output because we are using the same data set. Is that clear with everyone? Yes or no?
Yes, sir. Yes, sir.
Very good. That's okay because I just tell you why we are getting the same output. We are using a random state or a random seed of 42. So because the input random seed is same for every case, so over here also we have got a random seed of 42. That is why the output is same. If I change this, if I make the seed as 12 and make the seed over here as 25 or something, now you will be getting different outputs. So here I'm
Okay.
getting different result, and here also I'll be getting different output. So now my error is 13.02 and error 0.98. So all depends upon the random state that you are using. Whatever state you get, you by relation that you get different output. So far so clear. We are able to train the model. Now just training is not enough. We also need to evaluate the model for some inputs. Okay. To evaluate that, we'll come down. We'll first show the results of the model. So just copy this particular code from here. All of you refresh my code and just check this plot code might be there. Click on run and you should be able to get a plot like this. Okay. If you have got this plot, type yes on chat window.
Actually, how to where we can get this CSV file?
I'll show that, sir. Don't worry.
Smart irrigation data.
Yeah, I'll show that to you. Don't worry. Just let everyone respond. If you are able to get this plot, just type yes on chat window. Else you can just ask me if there is any query. Very good.
This plot where we will get, sir?
So when you run my code, if you refresh and run my code, you will be able to get this plot.
Okay.
Very good. So let me just explain this plot to everyone, what this plot is. As you can see, there are two kinds of colors in the plot. One is a dark blue color, one is a light blue color. Okay. The light blue color is the actual value of the data, as in the actual level of irrigation. And the dark blue color is actually the data which is we have predicted. So you can see whatever data we have got in the light blue, similar data we are getting in the dark blue color. If you want to change the color style, you can change from here as say red, and you can make it alpha as 0.1 and run the code. You'll be able to get a red output, wherein All the darker ones are the ones which we predicted, and the lighter ones are the ones which we have got as the output. Or you can also do a 0.9 over here. It will give you a better output. Okay. So are we clear on that? Yes or no?
I got only this blue color on this one. How to do this again? Red color, sir?
Just make color equals to red. The color equals to blue might be there. Make it red. You'll be able to get that.
Okay.
The color is not important. Any color is okay. But just understand this. Whatever output you are getting over here, that output, the points that you are getting, those points should match. As in, if the value of
Sir, this is a regression line.
regression plot, correct.
Yeah.
Okay. Now, let's move ahead and see how we can test this code and see how we can get the output. Okay. So what I am doing is just making a new code over here. I'll give a temperature level of 35, give a humidity level of 50, give a soil moisture of 40, and give a rainfall of 50. And I want to sow rice over here. And I'll say model.predict. If I do model.predict, this should be able to predict the irrigation level with this data. As in, if I click on this, it should be able to give me that if the temperature is 35 degrees, humidity is 50%, soil moisture is 40%, rainfall is 50 millimeter, crop type is rice, then the amount of water needed is 432.33 liters. Are we clear with that? Yes or no? Yeah. So if you want to run this code on your machine, refresh my code, you will be getting this particular new cell. Copy this cell and paste inside your machine and run the code. And whatever output you're getting, just copy the output from here and paste the output on chat window.
After refreshing, what we need to do, sir?
Just run the code, sir.
Run.
Yeah, sir, I'll share that file with you. Don't worry. That file is available on your PC as well. So if you want to check that particular file, go on the left side, you get files over here. You had a smart irrigation file. Click on the three dots and click on download. You can download that file.
Okay, okay. Now this predicted irrigation is 432.33 liters per hectare.
Yeah. Sanjay sir, you just click on run anyway.
Yeah, I got that, sir.
Very good. Yeah. So now we have got the predicted irrigation level as this value. If I modify the temperature, if I make it 20 degrees, humidity as 5, soil moisture as 15, rainfall as 20, and I now want to sow crop number 2, and I run the code, I should be able to get a different value. As you can see, change the input data and just see if you're able to get a different output based on the input. Modify the temperature, modify the humidity based on your choice. No problem. Don't copy my values. You can use your own values. Make temperature, humidity, soil moisture, rainfall, and crop type, and just check what output you're getting.
In that new sample input itself, we can change,
Yes. And make sure you do not remove the square brackets. These are required.
Okay.
Inside the square brackets. Because this requires a array as input. Very good. So now I think you are able to change the inputs and you're able to get the output as well. Now, let's understand that we are able to train the model. We are able to get the outputs. But this particular output that we are able to get, this output is actually not useful for the farmer because the farmer will not change the code and he will not run the code. That is why this particular thing is okay for a engineering point of view, but not for a farmer point of view. So to make sure that the farmer also is able to use this particular UI, what we have done is we have made a small UI in Colab. So just copy this particular code from here. I'll paste the code over here. I just
Sir, when we change crop type to true, it again shows rise only.
no, that is a comment, sir. This is not
Okay.
code, this is a comment. Okay, so let me just explain you what code I have pasted. We have imported some libraries. We have made this particular temperature and stuff, and we have trained the model over here, like we did last time. Now, we will give the user an input UI, where in the UI, we will ask the user to change the temperature level, change the humidity level, change the soil moisture level, change the rainfall level, and he can select whether it requires wheat, rice, maize, or cotton. And when he runs the particular code or when she runs the particular code, they will be able to see this UI. And whenever someone clicks on the submit button, they will be able to do predict irrigation. So predict irrigation is a function that we have built over here. It will get all the input data and whatever model we have trained previously, it will say predict the model. And if the predicted irrigation level is low, that means low irrigation is required in that particular area. So you can water carefully because you have limited number of water. So the farmer will be able to use the water carefully. Then if the irrigation level is less than 250, as in 250 liters are available, that's the moderate irrigation required. So we'll tell the farmer to ensure proper distribution, as in do not spill the water at one place a lot and you use it for proper distribution. And third, if there is very high irrigation level, then we will say high irrigation needed. Consider water conservation. As in you should consider some water conservation techniques. So based on this, if you refresh my page now and you run this particular code, you should be able to get a UI something like this that will be getting right now in just 1 minute. So this will be the UI that will be shown to the farmer. Actually, the farmer can select the temperature of the farm. He can select the humidity of the farm, select the soil moisture level, select the rainfall level, and he can select which crop they require. As soon as they click on submit, the model will be able to tell that the predicted irrigation level is 544.27 liters. Advice is high irrigation needed, consider water conservation methods. Now you modify the value of temperature, humidity, and rainfall and stuff, and click on submit again. You will be able to get a different prediction level. You change the level again, should be able to get a different irrigation level, and based on that, you should be able to get a different output. So whatever output you are getting, just paste on the chat window, and we'll be able to understand that you've got the output. I think Pinakam got the output very good.
It asks us to submit, sir.
You click on submit. Sanjay sir, I think you have to run the code from start, right? Start first code that you have got now. Run the code from the first thing. Yes, we can use Gradio on local machine, but actually Gradio is a web interface, Manish sir. I'll just show you the power of Gradio.
But
If-
the submit button is not, when we click, it will not work, sir.
on the right side, sir, you should be able to get output like this.
Right side.
Just look on the screen.
Oh, it is taking time, I think, processing.
Yes, sir, it will take some time. It will give you the output.
Okay.
Now, the main power of Gradio that we have just used over here is that if you want to host this particular code on a website, Gradio will give you a free website. Okay, so I think you might be able to get this running on public URL. This, click on this link, and you should be able to get a full screen UI like this. You modify the inputs, select the crop, click on it. The Gradio UI will be able to show you the output. This is a full-fledged website that you can show to your farmers, and the farmers will be able to use this website in real time. Okay, so Shraddha ma'am is asking, is the model being used inbuilt model? What is AI used over here? That's very good. So Shraddha ma'am, we are using a random forest regressor over here, which is working as a machine learning model. And that is doing all the intelligent tasks of predicting the output. Secondly, we have used a small recommendation engine over here based on the irrigation level, which is showing us the results. Second question was asked that what if these distances? That's very good. If you want, you can actually receive the data, temperature, humidity, and moisture from sensors, and then you can put those values over here. Are we clear on that, everyone? Very good. So this is how we can actually build a simple application from scratch using AI tools or using Python. This link is available to all of you. Whenever you want, you can just open this particular link and you can get the result from this particular thing. In case of any queries, you can ask me right now. I am available over here for the next 10-15 minutes. If you want, I can go through with you with one more case study, but we'll not code that because it will take a lot of time, but we can discuss some other case study. Yeah, that's very good, Mia.
What is the link we'll get, sir, in that workshop only?
Yeah, so I have sent the link of this code, right? This collab link that I've sent
Yeah,
you.
first you have sent the link.
This link I've sent you. This link you will be available with you. You can just use this particular link every time, and you can get the output. And if you want to get the link of the website, once you run the last code, you'll be able to get running on public URL. Click on this particular URL, and you will be able to get the full-fledged website running on your browser. Very good, Pavan sir. You have got the output.
Sir, good evening.
Good evening, sir.
Sir, thank you very much for this nice presentation.
Yeah.
I have a query, sir, one technical query.
Please ask.
Like whatever the sensors we are using in the IoT-based system, right, sir?
Yes.
Let's say moisture level, correct, sir?
Correct.
Okay. So the moisture level is varies as per the area expanding to some larger space, right, sir?
Correct.
So what will be our limitations that these sensors will trace the parameter up to like half acre or 0.25 acre or 1 acre? What will be our limitation? How we can define that limitation, sir?
Okay. So there are two solutions to this. One solution is that now we are showing the output in terms of per hectare, right?
Okay, sir.
If your sensor is only sensing an area of 1 acre, or the sensor is sensing the area of just say 100 meters, for example.
Okay.
So you can produce at the output that you have to use this much water for 100 meters only.
Got it, sir. Got
So
it.
based on your sensor, you can modify the training and the output set.
Okay, sir. That means, sir, whatever the ERP, that means user interface we have to define, that is completely based on the IoT hardware, sir. Correct, sir?
IoT hardware is correct.
Yes. Okay. Okay. Thank you, sir.
Yes. Anyone else? Please ask.
Sir, in my system, this after submission, in the output side, right side,
Mhm.
it is showing processing. It has shown 367 point, yes, like that it is going on.
Correct.
How much time it will take, sir?
No, can you share your screen?
Yes, sir.
Yeah, please show me your screen so that I can understand what is happening over there.
I think I am taking this in the laptop, but I'm taking in this in this one. Just a minute. I will share it. Let me see. Picture.
Yeah. In the meanwhile, if you have any other queries, please ask anyone. I think Sir have asked a query, Manish sir. So Manish sir, in today's date, if you want to learn about these tools technologies, I would recommend you to use Meta AI. Meta AI will show you exact answers for all the queries that you have got. But still, if you want to go the detailed way, as in if you want to read more into it, so YouTube channels are very, very good. They will help you a lot in this. Shraddha Ram is asking, do you need any backend APIs for real-time purpose? Thanks, Manish sir. So this particular API that we used, the Gradio API, that can be used for real-time purpose as well. So right now, if you want, if I send you this link on your chat window, you can click on this link on your machine and you can actually run the code that I showed you on my collab. So they have actually linked the two together. This can be done for real-time purposes. Yes. Here we know. Please ask.
Ashwin sir, what if if we want to make changes regarding if I have a set of this thing available and the field is having this much of moisture, temperature, and if I wanted to know what kind of crop could be grown over there?
Yeah. So in that case, I'll just share my screen once again and I'll show you how you can do it. Do you see over here we have given X and Y?
Okay, right.
So I'm just changing the code. I'll just make the code as it was previously, but just be over there. I have to, the inputs will be temperature, humidity, soil, and rainfall, right? And the output is crop type. So I just remove the crop type from here.
Okay.
I make the Y as crop type.
Okay.
Remove the crop type data from here. Okay. Now,
Right.
based on this, if I run this code, the model will now be trained on the crop type. Okay.
Okay. Right.
And now, if I click on this particular thing, I don't have to give it the crop type. I only have to give it temperature, humidity, and so on. And I'll say predicted crop type.
Okay, so inputs and outputs are getting changed. Okay.
Yeah. So if I run the code now, you will be able to get predicted crop type as 2. 2 means when we went over there at the top, 2 was maize.
Right.
So you can just print this statement as well at the output, that what is the crop type. So I can just print this at the output. If I modify the temperature as 15 degrees, humidity as 25, soil moisture as 40, and rainfall as 50. If I run the code now, it will be able to tell me 1.74, that is rice or maize you can sow over here.
Okay.
So based on what input you are giving over here, based on that, you should be able to get the result. I hope
Right.
that's clear.
Right, right. Okay. And
So-
even like if we need to change other properties, like we are like right now dealing with temperature, humidity, rainfall. So if other parameters are to be included or some are to be deleted, accordingly we'll make the changes in X and Y coordinates.
Yeah, you can just modify these values from here.
Okay.
And you can also modify, let's say if I want to add one parameter, let's say I want to add, let's say elevation. Okay, so elevation
Okay.
will again be a value in terms of meters, and let's say
Okay.
0 to 10 meters the elevation level. Okay, and
Right.
the output is again, I'll just make it plus elevation into 0.5. Then we just make it over here elevation as a new column, and we
Okay.
make it elevation over here. And when we run this code now, we get an elevation column. Can you see this?
Okay, right, right,
Yeah, and then we can also add the elevation column over here.
right.
And when we run this code, it will train on the elevation column as well now. Show me the output. And now if I want to change the UI, I just simply give over here elevation as say 5. And if I run the code now, I just comma over here. In the code now, I should be able to give me the irrigation level. Similarly, whatever inputs I have given over here, the previous inputs, I just copy them here, the entire thing. And you can also modify the UI, as in you can add the elevation level in the UI as well. It's a very simple task. It's not that difficult. You just copy and paste from here to there. Just pasted this part, and I just add elevation.
Got it, sir, got it. Right.
And then based on that, you should be able to get the output. I'll just complete that thing for the sake of completion.
Okay.
And I have this rainfall radio, and I just have elevation over here. Elevation meters, this one will give you 200. This should work. Run the code now, you should be able to get the output. It will come in a minute, the UI. So now you can also have the elevation as well over here. And based on that, you should be able to get the result of the amount of water. There might be some error. I'll just check what error is there. But you can add this thing over here, no problem. You got the point, ma'am?
Yes, yes.
This will be elevation. One more include over here. Now it should work. So it's that simple. It's not that difficult to add.
Right.
You can also always add and remove the inputs as and when required. And based on that, you should be able to get the output in terms of the number of irrigation required.
Done. Thank you.
Any more queries, please ask. Ready, sir? Any query, please ask. So, Ready, sir? Any queries, please ask.
Sir, if I wish to contact you, how can I contact you? Actually, I missed certain portion due to my engagements in my office as of now.
Sure. So I'm sending you my contact details. You can call me at the number that I have shared on the screen.
Please.
And you can also email me at ashwinbalani@gmail.com.
Yeah.
So in case of any queries with regard to this workshop, with regards to any other, what you can say, work, you can simply give me a call or a message, and I'll be there to assist you with that.
Yeah.
Yeah, I think everyone has got my contact details.
Yeah.
Perfect.
And time convenient to you as if
Yeah.
I want to call you?
11 to 8, I'm available. From morning 11 to evening 8, I'm available. You give
Yeah.
a call at that time, no problem.
Right. Thanks a lot. Thank you.
Thank you. Thank you so much. Yes, any queries, please ask if you have. So
Any
this-
queries? Yes, participants? If it is done, please put a message as done on the chat box.
Sorry, sir, raised his hand.
That's perfectly okay. So I have also modified the code with the elevation input, and I've saved the code as well. So if you want, all of you, you can use that code with elevation as the input added in the link. So you can just use that. Any other queries if you want to ask?
Ashwin, sir, I have a query like,
Yeah, please.
if you're using this workbook.
Yeah.
It will be requiring your access, right?
No. You can directly use it now. I have given access to everyone.
Okay. So anytime it can be used like,
Yes, anytime you can use it, no problem.
okay.
So it's basically a what you can say shared notebook wherein everyone can just click on that link and they can use it. Thanks, Meenakshi ma'am. Thanks, Ritesh sir. Yes, any queries if you have with regards to any more examples you want to discuss, or if you have any particular query, just please ask me. Thanks, Pinaka sir. Thanks, Kamlesh. Thanks, Manisha ma'am.
Actually, certain fundamental research related to agri crops you must have done before putting on your efforts in coding.
Yes, correct.
So just I would like to ask you, which was the resource, what resources you've referred?
So first thing is the collection of data. So there are multiple websites like NCCB, there is a website like Kaggle, there is a website like IEEE Dataport, there are like GitHub resources available. So we first collect data from those resources. Then we try to understand the kind of patterns that we get in the data, as in are we able to get the irrigation level? Are we able to get the quality of soil? Are we able to get the type of crop that can be put inside that particular soil? And then based on that, we create our own models with the help of RNN, CNN, or random forest, and then we test those things on that data.
But how much time you took to validate your models as far as your actual cropping patterns are concerned?
So it's a continuous process, because every time we get a new data set, the model accuracy goes down or goes up. So depending upon that, we need to just keep on like continuously like tuning that. So Sashi said this particular model uses only random forest. If you want, you can actually use ensemble of different models, as in random forest, then linear regression, then spline regression, and the combination of that can also be used for regression output. So that will actually help you to increase the accuracy.
Very nice.
Yes. Yeah.
Actually, as a part of like a certain important project curriculum, I wanted to introduce these concepts for my
Yes.
students.
Yes, sir.
So that's why I asked you to just share your contact number. Like as and when both of us are available for a mutual discussion, we can discuss this thing.
Sure, sir. Please. After the session, you can give me a call. We will definitely discuss on that.
Sir, I shared my screenshot through WhatsApp. If you can just see that, because I was getting only that result I am not getting after submission.
Okay. So Prabhakar sir, I think you should refresh the code once, because I
Okay.
think this code is running on my collab.
Okay.
Can you do one thing? You can click on File
Yeah.
and then click on Save a Copy in Drive.
Clicking on
File and then
File.
click on Save a Copy in Drive.
Save a copy in Drive.
Yes,
Yeah.
so that will now copy the entire code into your drive. So now you can use that particular code anywhere. Like even if my code gets deleted, you will
Okay.
have that code in your drive.
Okay. Thank you, sir. Thank you.
Yeah. Now you can run the code; it will work properly.
Okay. Thank you, sir.
Yeah. So I think a lot of thanks are in order. Thank you so much
Thanks a lot.
for the appreciation. Yes, sir.
Thank you. So if there are no more questions, we'll. Fine. So it was a fabulous session, sir. Very informative. And we
Thank you.
learned a lot from the new software that is Collab.
Yeah.
The practical hands-on always bring a lot of life to the session. So thank you so much. It was
Thank
worth listening and understanding. Thank you so much. And thank you for all your patience, clearing out all the doubts.
Anytime, ma'am. And thanks to all the participants that they were there for the entire thing. And just keep coding. And in case of any queries, you can just give me a call. No problem.
Definitely.
Thank you.
Thank you so much, sir.
Really, thank you. Thank you, everyone. Thank you.
Thank you.
Thanks a lot once again. Thank you.
So participants are requested to please write down your comments on the feedback form. The feedback link will be provided to you on the WhatsApp group, and the link will be shared here as well. So please provide the feedback and please do give the comments. And we'll be joining the next session within 5 to 10 minutes. So stay connected. Thank you, everyone.
Thank you. Ma'am, I have one query.
Right?
Ma'am, can we get these presentation details?
Sure, sir. I'll let you know.
Okay, thank you.
Okay.
Yeah, if you require the presentation, I can just share a collab link. I'll just share a
Okay.
file link to all of you.
Okay, sir.
All of you can actually get the presentation available right now. Just give me 1 second. I'm just uploading that on my drive and share with you guys. This is anyone with the link, copy. Yeah, I've shared the link with you, the collab link. Just click
Okay.
on that link, you'll be able to get the presentation, everyone. Just click on that link and you'll be able to open the presentation.
Got it, sir.
Yeah,
Thank you so much.
Thank you, ma'am. Thank you.
Yes, it is getting downloaded.
If possible, can we get the recordings of the session later on so that we can refer to them?
Yeah,
Sure, sir.
definitely. If you can get the recording, it will be helpful, madam.
Yeah,
Definitely,
please.
sir. We'll provide
Yeah.
this.
Yeah, thank you.
It is a wonderful session.
Thank you. And Ashwin, sir, really thankful to you.
Thank you, ma'am.
Even organizers,
listening to you.
they also deserve the same basically.
Yes,
Hard work from your end also.
yes, 100%.
Yeah.
So thank you, everyone. We'll be connected in 5 to 10 minutes from here for the next session. Thank you.